Hello everyone and welcome back to my channel. If you're new here, my name is Aparna and I've been a senior software engineer at big tech companies like Netflix, Yahoo and Zynga. And in this video, we are talking about teaching our kids to code, whether we should do it or not, and if yes, then how? I've been a software developer for the better part of my life, so I know a thing or two about coding and programming and how to teach it as well. Also, I'm homeschooling my 4 and 7-year-old kids, and I will be breaking this video down based on ages. So what can a 3-year-old do, a 4-year-old, a 7-year-old, a 16-year-old, and beyond? I'll also be talking about what is the difference between software engineering and coding. And towards the end of the video, I will share everything that we do in our house to teach our kids to code, step-by-step instructions of all the projects that we do and the ones that you can replicate in your own home. There will be a short discussion about whether non-programmers can teach kids how to code. And so if any of that interests you, just keep on watching. So to start with, what is coding? The simplest definition of coding is to write step-by-step instructions so a computer can perform a specific task. Coding and programming, these two words are used interchangeably. I don't think there's a difference. If anybody were to tell you, it doesn't matter, it's all semantics anyway. There is, though, a very big difference between coding and software engineering, and we're gonna cover that in a minute. So, how do you teach coding to kids? My number one rule for teaching anything to children is that they should be interested in it. And to make it a little bit more difficult for myself, I teach coding to my kids without using any screens. And the reason is they will be exposed to screens for their entire lives. And by limiting this resource, we are teaching them creativity. Every time you take something away from somebody, they are going to figure out a creative way. And that's why I'm challenging myself to teach coding to my kids without screens, because there's also this added benefit of having no distractions. Next, should we be teaching our kids how to code? To answer this question, let me pull up this interesting article that I came across. Software engineer dad wrote this article and it says, "I'm a developer, I won't teach my kids to code and neither should you." Let's see what this is all about. Now here, the dad mentions that coding is not the new literacy. You might have heard many people say that everybody should know how to code, this is the new literacy, but I kind of sort of agree with him that coding is not something that all the parents know. They know how to read or write, but they can't teach or even do coding themselves. So it may not be the new literacy, but that is irrelevant. Now, the reason this dad said that earlier in his career, he had to configure and run a group of remote servers, and then eventually the server started failing. He had to stay up many nights, and it took him weeks to figure out what was wrong with the server deployment and debug it to fix the systems. So this article sounds like we shouldn't be teaching our kids how the basics of the human body or the human heart works just because they shouldn't be allowed to do surgery. I don't agree with that, but one thing I do agree with the author is that no kids should be forced into learning coding because it is a new literacy. Of course, they should not be forced to do anything, whether it's math, English, science, or anything, any learning opportunity, even sports for that matter. The first step into teaching coding to your children is, like I've said in my previous videos, observe them, see what interests them and what challenges them. If something's too easy, make it harder for them. If something's too hard, you do the hard work and let them do the work that is at their level. That being said, I totally think that we can teach coding to kids because if we break it down into fundamentals, programming, even software engineering is nothing but problem solving. So we can teach our kids problem solving. It's the mindset that we are building and not really the need to sit down and write programs to do unnecessary tasks. Why would we ask our kids to do any unnecessary tasks, especially if it's not interesting to them? Like, we don't go and wash the dishes that are clean just because we should do it. We only do it when it's necessary, when they're dirty. So the same thing applies with kids. If it is interesting, if it's challenging and stimulating for their brain, we can teach them these basic principles. All right, all of that being said, let's jump right into what our children can and cannot do. And here I'm gonna break down things into different age groups, but they're not rules. This is just my understanding. You know your child the best. So if you think that your 3-year-old is a savant and is extremely interested in sitting down and writing complex instructions, by all means, have your 3-year-old sit down and code. But Jokes aside, if we are starting with the age group of 3 and above, even 2 and above, I would just say the best way to teach them how to code is take them outdoors. Yes, there is nothing that a child learns more than how the world works. They need to see some waves crashing, leaves rustling, the wind blowing, things falling through gravity. Just the fact that they're outside and they see the sun rising and sun setting creates a rhythm inside their body. They understand structure. They kind of sort of understand nature's laws. That's how you teach a 3-year-old coding. We don't have to have them sit down and learn for and while loops, really. But if you insist on doing some activities that you think might prime their brain for programming later, you could go outside and collect some sticks and have them sort it based on length, or take some pebbles and create geometric patterns with those pebbles. Just let them do a lot of free play and they will start understanding the structure and the laws of nature. As an example, the other day we went to the stream. We go to the mountains every single week, and at the stream, my kids figured out this race course for racing their shoes. How cool was that? All that these kids needed for 2 hours worth of play was 2 shoes, and they kind of cleaned up the stream. It was like very shallow water area, and they removed all the blockages in the rocks, and they raced one shoe against the other. This is logic. This is problem solving. This is coding, right? So encourage a lot of free play, unstructured play, because you know what? When they are going to become those software engineers and the servers are going to fail, all of these problems are going to be unstructured. These problems in real world, they don't play by rules. You know, somebody's learning tennis, there is a certain set of very controlled rules that this sport has. That's great if your kids are learning organized sport, but way more important than that is unstructured play, serendipity, and figuring things out by themselves while resources are constrained. This is exactly what we do when we're working on big tech company projects where the scale is more than 200 million users seeing our code. They don't really see the code, but the product that the code creates. So your best bet is to really support and enhance their brain development by lots and lots of outdoor nature, unstructured play. All right, so this was all about very, very young kids. Now, if your child is 5 or 6, they are starting to read and write, there is some literacy going on in their brains. This next section is going to be really fun. It's a Lego coding maze that we worked on with our children. Again, they're 4 and 7. They can read most of the basic words now. So this was a lot of fun with my daughter figuring the instructions out. And shout out to the blog researchparent.com, from where I got all the printables. I just printed out everything and we cut it into pieces, and we had all the instructions to lay down.
We set up the board and mapped each instruction to a move of our little Lego guy. The goal here is to help the guy find a path from start to end. As a bonus, my kids helped me create this stop motion animation for the YouTube video. Here I have set up the next advanced level for the instructions in the Lego maze. As you can see, there are 2 go forwards here, 2 go forwards here, 4 and 2 again over here. This is very repetitive instruction. What we can do, instead of having 4 go forwards here, we can replace it with a for loop that says for 4 steps, just do 1 go forward and end. Similarly, for the 2, we can do for 2 steps, do 1 go forward. These are smaller numbers, so it doesn't make a huge difference in the number of instructions that we reduced. But imagine if there were 17 go forwards, and if we had to replace that with 17 steps, go forward. And then many languages need a sort of an end indicator, because we don't want the rest of the instructions to be executed 4 times or 17 times. This is the next level of thinking when we write code, because this is very useful
and reduces the complexity and also the length of the code that we write. I have purposely not shown this to my kids just yet. I really want to have them discover it. I have been brainstorming about a problem where they come across something that needs to be done 20 times and they'll figure out a way to make that compact. Of course, I'll drop hints here and there if it's getting too hard for them, but I call this discovery-based learning, and I'm very excited to see what my kids discover as we go forward in this process. There are these 3 containers and they contain 2 pegs. One container in the middle is empty. What we want to do is swap the 2 pegs without moving the containers. So can you try to swap? Swap without moving the containers. So the middle green one needs to go where? We're swapping the red and green. Where was the red? Great. So now the swap is complete. You didn't move the containers and the green and red swapped positions. Okay, now that we know how to swap 2 objects in place without moving the containers, we are going to use that same concept to sort this sequence. Can you tell me what these numbers are?
7, 3, 5, 6, 8, 4.
Are these sorted?
No.
And the way we want to sort is the smallest will be here and the largest will be this side. Okay, so that is called ascending order. The way we want to do it is every time you start from here, from left to right, you're going to look at these 2 numbers. If they are in place, leave them as is. But if the left one is bigger than the right one, you use these containers to swap them. Okay, I'll show you the example first. So this goes here, just like the pegs. Now can you swap them? You want to use the middle container because what happens in a computer is that these things cannot be in the air. One needs to be somewhere placed. Okay, let's try again. Okay, this is how we started, right? We want to swap them. Great. Now take both of them and place them in the order that you swapped. Perfect. So looks like these first 2 are swapped. Now you can check these 2 and do the same thing. Okay, let's move on to the next one. Good, you remember the position. Now, these 2, do they need swapping? Do they need swapping? No, this and this. 8 and is that 7 and 8? Do they need swapping? No. So you leave them as it is and then move on to the next one.
Look, I have a double head.
Okay. Great. Now we've gone through the whole sequence once, right? From left to right. But hold on. Does it look sorted? No. So what we'll do is we want to check for, we want to go back to the left and start checking one more time. And we'll do this till we are done checking. So this guy is at the very right and it is the largest number. So that means till this position, we are good. But now we have to start doing the same operation from here to here. Got it? So let's check again from left to right.
No swap, no swap. This is good, good, good. Oh, these need to be swapped.
Okay. That means now these 2 are done. We're gonna look at the sequence from here to here.
This is all good. This and this need to be swapped. So,
The last three are now in order.
yes.
And
Now,
we have to work with the first three.
5 and 4 need to be swapped. Now everything's good.
So now we have a sorted sequence.
That's called a bubble.
Now this type of sorting is called bubble sort. What is it called?
Bubble sort.
And what you are doing here, putting things in these containers and swapping, that in computer science we can call it a method. You were doing the same thing over and over, right? But you were just changing the numbers that go inside it. So you were calling a method multiple times, as many times as you needed. You would just change what was going inside these containers. Next, in this example, we're not coding, but working on math concepts like division with concrete objects. This will help the kids understand units, tens, hundreds, and thousands to manipulate numbers in computer code easily. We also worked with problems with remainders after this exercise. This type of concrete division can help them write a program that can reverse the digits of a given number. For example, 4321 in reverse will be 1234.
Put one in each. Now, how will you divide that?
See how it's 111?
We continue breaking the larger units down into smaller ones till we fill all three baskets equally. This is a problem with no remainders.
You know why 5 times? Because I'm putting one in each. Because 5 threes are 3 5s, is 15.
Yeah. Okay. Now, let's just pick up any basket and see what's the answer.
See how you think it's 0? See how you think it's 0? Actually, now
Ah. That's the answer.
it is 1,525.
Next, if you don't want to do any of this printing work in your present time, our kids have been working with this game called Codemasters that I got from Amazon, and I'll leave the link down below. They've had the most fun. I think the first day my daughter finished 20 levels. One of the levels was very challenging. Like, it took me and my husband 2 days to figure it out, but it's not very complex. Even if you're not programmers, you'll be able to guide your kids. Just read the rule book and they will learn a lot of like graph traversal and resource management. If you play this game, you'll see how. I will insert a clip right here of an example of my kids playing this game.
So this is the avatar. This is where you start. You start on the number it says here. In this case, it's 1. I'm doing level 4. This is the avatar. The portal. This goes on the number that's shown, which here, it's 5. So I will put it here.
1 is the start and 5 is the end.
And then there's a gem on 3 and 4 that we have to collect on the way. On this paper, I will write the things. So I have these. First,
Why do you have those?
so these will tell you what color to go across. First, I put a blue. then red. I chose these because they're written here. Blue, red. Then I will put a green. Then another blue. Then another red. So let's see. Down the blue. Down, straight the red. Collect the gem. Straight to 4. Collect the gem. Go around blue. Turn to 5. And then I win.
That was easy.
Finished. Now I'm gonna do one more that is
Pretty fun.
pretty fun, and it has all gems. Let's see, where is it? Level 16. I've done it before because I'm past 16.
Here they show us where we start. The starting position is 1 and end is 3. That's why the starting avatar goes here,
It's easy.
and then the portal is the end
Red.
where we go to 3.
It's easy. Red, blue, green.
Blue. Green. Wait, it's not red, blue, green. I have to put this action. That means red. Pick up 1 gem. Blue. Pick up 1 gem. Green. Is it finished? No. So I go back. Red. Green.
Can you explain why you're going back?
I'm going back because I have this action token. That means you have to collect 6 gems. One more time and I win. Daddy thought I could collect all gems at once, like 3 at once, but it was actually 1 at once. You told me that. School holiday stuff.
It's interesting because I thought that this 6x means that this stuff needs to be done 6 times.
It means you have to go around to collect all 6 gems.
It's okay. Why is the 6x
So,
not taking you around the loop 6 times?
So the 6x is a conditional check. It says, do you have 6 gems yet?
Okay.
If you have 6 gems yet, go to the green check. If you don't have 6 gems, then follow the red path. And then the red path will take you back around here, and then you repeat these steps. And then again check. Then if not, then again you repeat these steps and then check. So it goes loops with that condition.
So it's a if, not a, it's a while.
It's a while.
For the 6 and older group, another thing that you can do to create the coding mindset is play strategy games with the kids. For example, the game Settlers of Catan. First, we started with the junior version and now they have graduated to the next level. And this is the game that we started playing as adults like 10, 12 years ago. And the kids have gotten a really good understanding of all the strategies. They are learning budgeting their resources, sometimes backtracking, making multiple decisions, and especially probabilities. So any kid 6 or more should be playing these strategy games, creating this mindset for what can I do in the most limited resources, because so much of software engineering and programming is managing resources. Your operating system that the computer runs on is always managing and juggling resources, putting things in queue, taking things out, first in, first out, or last in, first out. Even a small concept like that can be translated into a game or just the concept hardwired in the real world. Another thing you can do is take concepts like object-oriented programming, where there's a vehicle and a car is a type of a vehicle and boats are types of vehicles. So are planes. right? So this is a relationship. We use that a lot in object-oriented programming in the real world. So if you already know computer science and you're a computer engineer, you'll be able to translate lots of these concepts directly into conversations, into activities with your kids. Now that brings me to my next point. Can non-programmers teach kids how to code? And the answer, according to me, is yes and no. There are all of these things that you can teach to your kids, like sorting, searching, and anything that you have used in a computer. You can talk about those concepts, but I would say that you will need a little bit more curiosity than just randomly scrolling through Facebook or Instagram. Just go and put on your thinking hat and have a conversation about how must these websites be loading. When you have something on your desktop, why did they call it a desktop? It is called a metaphor in the human-computer interface sciences. And if you put on this curiosity hat and have these discussions with your children about what the computer world really uses and how it works, then together find out answers to these questions. So as a non-programmer, the best thing that you can do is put on your curiosity hat and ask questions, discuss with your children, how must this be working? And all the answers are on the table. There are no right or wrong answers. Let them come up with solutions, maybe find moments of discovery and invention. And if you so desire and get interested, start learning some coding. There's tons and tons of tutorials on YouTube and free coding courses online on Coursera and Udemy. So you can take like a basic coding course, and of course after that you'll have much more to teach your kids. And if you are a software engineer, I would highly recommend, again, letting them discover and figure things out by themselves instead of just giving them the information and saying, okay, this is a for loop, this is how you write a for loop. Let them write repeated statements for a while and get frustrated, and then they come up with the solution of, I wish there was something that could encapsulate this, do this 10 times, you know. So just with any other subject, if you are creating curiosity for your kids and moments of joy, wonder, and discovery, they are going to be able to learn much better. For kids that are older, 13 and 16 years or beyond, there's no limit. Of course, you can just go on YouTube, start learning programming languages like Python, JavaScript. I wouldn't start with C and C++. They're very frustrating, especially if a child is just going into their entry level and wants to play around with certain things and just have the joy of programming. I really wouldn't introduce C and C++ just yet. Let them fall in love with programming. And if they need to go for a computer science degree, they will be taught those languages over there anyways, and they will feel the pain of pointer management. Honestly, like once we were done with those courses, we graduated with our degrees. In my day-to-day job, I never used, well, never say never. Back in the day when I was doing iOS development, we used some pointers, but just in general, do not overwhelm. Just that's the advice when they're starting out. Let them start with the fun stuff. Let them get interested. And it's a very lucrative career. This is definitely a high skill, high paid job, especially in developed countries, Western countries, and big companies. So if your child has interest, I would highly recommend them going this route and, finding their financial freedom just like I did. And now I have so much more energy to do these videos and teach my kids at home. So I think computer science, learning it's a wonderful gift we can give to our kids. We have to be careful with not overwhelming them because these systems can get complex very quickly. But there are tons of things we can do to teach our kids of all ages. With those examples that I've already showed you, if you have any more specific questions about certain areas of computer science or just curiosities, let me know. I will try to put down as many resources as possible in the description box of this video. So even if you want to start learning how to code as a parent, you can start your journey there. And yeah, have lots of fun with it. Programming is extremely creative and a joy when it kind of starts to flow. I don't know how many countless hours I've spent just writing code and getting lost in the flow state of it. So I wouldn't stop any young children from learning it, especially once you give them these resources and they start getting interested in it. And once you think that you have completely run out of resources when not using a screen, then of course, you can start showing them how to write programs on the computer. Once they can read, write well, I would say like 9, 10, 11, maybe even 13 years of age, that is a good time to start working with screens and making real projects. But you know your child the best, and whatever is more convenient for you. I just believe that I will keep the distraction of screens away and let them learn the basic structures of programming through life and through these projects. I hope you enjoyed this video, and if you want to know why I started homeschooling my kids or how I do it, I have made 2 very detailed videos about this whole process, so go check them out, and I'll see you in the next one. Bye.